Hi, I'm Isla from Matterhorn Studio, and today I'm going to be showing you how you can speed up your R&D efforts using active learning in just a few clicks. So our Google Sheets plugin that we've developed here at Matterhorn can speed up your experiments because we've packaged complex machine learning algorithms into a simple, intuitive, and free interface that you can find here as an extension on a Google Sheet. So you would just search for our app here, Matterhorn Studio for Sheets, and I've already installed it, but it's a very easy installation process. So you can get started using active learning with no coding experience and no complicated software installation. So in this example, I'm going to be using HPLC data, but you can also apply this to a range of different experiments you wish to optimize, for example, chemical reactions or materials formulations, and more. So HPLC, or high performance liquid chromatography, is a very common analytical chemistry technique that's used to separate components from a mixture, and it's used very, very often in pharma applications. But it can be very tedious and time consuming when you're developing a new method. That involves a lot of trial and error, or traditional design of experiment methods can also be very tedious. I'm going to be using data from this paper, which was published in 2024, and this paper was in collaboration with Pfizer. So I'm using this data. So here on our Google Sheet, we have our 7 different experiments with our inputs highlighted here in blue and our outputs in green. So in this experiment, we're trying to separate a mixture of 11 compounds using HPLC. And this is our data sheet, which we select here in the first step. The next is you would select your input column. So here I've highlighted these in blue, and these would be your inputs. And now your outputs are highlighted in green, which we'd set here. Now next you want to select a parameter sheet or create a new one. So here we are going to be creating a new one. And you'll see here it's generating a new parameter sheet for us. So here you'll have your inputs, and I'm going to be using the lower and upper bounds, which was taken from this paper. And this is quite important because, say for example, you know that your column can only have an initial organic modifier concentration of between 5 and 60%. Otherwise, it might damage the column. You don't want the algorithm to explore options out of those bounds, so you can set those bounds accordingly. And then you have your decimal precision, which is set here as 2 for default, and your data type, and these are all continuous variables. But there is the option for if they were discrete or categorical. And your objectives. So this R/crit value is just a measure of how well your peaks are separating from one another, so how well your compounds are separated. So you want to maximize that. And then the number of peaks you also want to maximize because you want to separate all the peaks possible. But that's a discrete variable. And then for the time the last peak elutes is essentially how long your experiment's going to be, how long that run will be. And you want to minimize that because that'll save you time and it'll save you money. So next on step 5, you can set the desired number of recommendations that you want. And here it's set to 3 by default, and this will just be the number of experiments that the algorithm will generate that you want to try next. Next, you want to determine the degree to which the algorithm will explore or exploit the bounds, 0 being exploit and 1 being explore. And here it's set at 0.5, so in the middle, where the model is balancing between exploring new options and exploiting good known ones. So this allows the model to keep improving while still refining what it already knows. So now you're ready and you can press calculate recommendations. So now the Matterhorn plugin has used active learning, so Bayesian optimization, to analyze our results from our previous experiments and suggest new experiments predicted to improve our results. And you can see here that a new sheet has been generated, and this will show our recommendations that the algorithm has given us for new experiments to try. So what you'll next do is you'll go into the laboratory and try out these new experimental conditions and record your outputs and then feed that back into the algorithm. So this figure from the paper I mentioned earlier summarizes this very nicely. So you had your initial conditions and your outputs, and you fed that into the Bayesian optimizer, so our Matterhorn Studio Google Sheets plugin in our case. And then that gave you a set of recommendations to try next. And once you conduct that in the lab, you'd run your HPLC method, you'd get your results from that, your outputs, and you'd feed that back into the optimization loop. And over time, it will lead to smarter results and better results as you add more and more data. So this will mean fewer wasted runs, more efficient separations, and ultimately better results for your research. So you can try our Matterhorn Studio Google Sheets plugin today on your own data for free, and you can let active learning revolutionize your workflows. And you can contact us here for more information on matterhorn.studio. Our webpage has a lot more information about this plugin and a range of our other products. So, and you can get in touch with us for demo requests and future requests. So just let us know.